the fields we can explore in these battery pads modeling, because there are battery pad is one thing, but it involves 3-4 different softwares for designing, developing, and doing the prototyping for them. So for today's session, we will be restricting ourselves with 3 softwares: SolidWorks, ANSYS, and MATLAB. And we will be exploring the ways what we can do in these softwares for ourselves. So let's go ahead and start with our. So for the battery pack designing, we have 3 things. One is the designing, which we usually do on the designing software like SolidWorks, Stadia, or something. And then we have a analysis. In the analysis part, we have heat as a major trouble causing our battery cell. So please, everyone, mute yourself. We will be taking the questionnaire after the end of the session. Thank you. So yeah. So regarding the battery pad modeling, so as the final product battery pad, it required 3 different things. One is the designing that we usually do on the software like SolidWorks, Stadia, right? And then there is the analysis part, which require multiple analysis. Among them, the thermal analysis is the most important part, because nowadays you can see in India a lot of trouble are happening, a lot of burning effects are going on with these batteries. So heat transfer and heat propulsion in this ANSYS analysis part is another important aspect. And then we will be moving towards the end of that is a MATLAB, where we can design and code our BMS battery management system and help in advancing our battery's life. So for the first thing, what we usually do with the battery pad designing is the cell, right? So what exactly is a battery pad? Battery pad involves hundreds of cells, either in the configuration of parallel or in a series, or they can have.
Sir?
Yes.
So your screen is not visible.
My screen is not visible.
Yeah.
It is visible. We can see.
Once go down, sir.
Is it visible?
Yes, it is visible. You are right now on the introduction slide.
Yes. Now I have moved it to cell selection.
Yes, it is a cell selection.
Oh,
Sir, somebody else, I guess, had
Scroll
the
down.
screen, so it's not visible right now.
someone else is.
Puneet, what you can do, you can just reshare our screens once again.
Yeah, just reshare it.
I think someone is.
Your
Sir, you can just scroll down. If you scroll down, you can see the screen.
Just a minute.
Yes, you can scroll down.
Is it visible now?
Yes, sir.
Yes, sir.
Yes, sir. Now it is visible.
Okay. So yes, for developing any battery pad, there is most important part among them is the cell selection, right? So what exactly is a battery pad? Battery pad is a configuration of cells in the parallel or in a series pattern, right? So they can have both parallel and series simultaneously. So we will be exploring them. We will be having those in designing our designing point, right? And then for what these software help us is in the understanding what could be the reason for their failure and how we can increase its efficiency, right? So there are various things into this. We will be exploring them. So for the first part, right, the battery pack design. You can see in this image, these all are cells, right? And these cells are put in a pattern. These flat head that you see, they are into the negative, they are the negative ion capability, and these point which are they are the positive source, right? So when you arrange them, if you see this parallel thing, this tab, this is the series. So if you see this cell arrangement, this is the series thing attached. So you can see 1, 2, 3, 4, 5, 6, 7. 7 cells are attached in the series. And then if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 cells that are arranged in the parallel series, right? So for designing these, so SolidWorks comes very handy. What we usually do is we take all the dimensions, right, and then put our cells such that we can efficiently minimize the volume and efficiently increase its who is doing this. So so SolidWorks help us in efficiently optimizing our performance in terms of volume as well as in terms of the ranges, right? So you can see how we are connecting these top parts. If you can see my cursor, these top parts, these are the connecting point. So they are at the end, they are connected to the one source, that is the BMS, where we operate the heat and everything, which is the source for the direct interaction for ourselves. And once we move, and in the designing part, there is one more thing which is most important after the selection of the cells and these things. So we have an enclosure, right? So during when we put these cells in the pattern, we cover them up with the material like FR4, where FR stands for the flame resistant material. So if something, suppose some cell is bursting, so these cover comes handy. They don't allow this burning to go out. So between these cells and the cover, there is one more layer of material, that is FR4, FR6. Usually they are used in the electronics. FR6 is a material which are used in the PCBs. They are kind of a laminate. You can either use them as a laminate or you can either use them as a cloth. They are not a cloth, but you can cover them up as we wrap some cloths over the cells. So once we do these kinds of arrangement where we have the calculation for like how much voltage and how much current we require, we arrange this and then we wrap around them FR sheet, maybe FR4, FR5, but FR6 we don't use FR6 into the battery pack modeling. They are majorly used in the PCBs for lamination around, so that PCB doesn't burn around. So if you see the enclosure, you can these enclosure can vary. The material for these enclosure can vary depending upon the usability. So suppose if you have a two-wheeler, Ola or Ather or some two-wheeler EVs, so there you most probably be using plastic, right? But if you have autos, right? EV autos or three-wheeler. Sorry?
Dear learners, this was the last warning for you guys. If you are again unmute yourself, we'll wrap up this webinar. request all of you, do not unmute yourself. Puneet, you can continue.
Sure. And for those who have queries, we will be taking the queries at the end. So 3P or hand raised, we will be asking the queries at the end of these. So yeah, so enclosure design, this is also an important part that we usually do in the designing software. So for material thing, we have, it is dependent upon the usability. Suppose if you are into the two-wheeler EV space, then most probably you will be doing the plastic mold, and you will be using the enclosure as a plastic material. And for the this thing, autos and three-wheelers EV that we have, we generally go for the metal. And between those metal, we use FR4 or FR5 sheet for insulating them completely. And in this, what we do is we usually go with the nut and bolt arrangement. We have a head. If you see it, we have a head point. This is the top at the top part. At the top part, we generally put the BMS or the GPS system, because for tracking the batteries, if you see, for tracking the health of the battery and state of charge and state of discharge, we require the BMS, which we completely put at the upper part, so it can be easily accessible. That is dependent. If you can give an external part or easy access to the BMS, if you are into the battery swapping thing, right? So it will be a good idea for you to give a easy access to the BMS. Otherwise, if you are into a full-fledged battery selling and these things, you are not required to give them the BMS access easily, because that is something you will be taking the data of, and it shouldn't be accessible to the customer as easily as possible. So yes, for the batteries enclosure, yes, for the shape and size in this pattern, for the what you see on the screen is for the electric bike, right? For these, we can change up the patterns and the shapes of these enclosure, but generally they are into cuboids rather than cube or this thing, and they have external fins. Suppose if your material that heated, so these sorry. So what you see at the outer edge is also act as a fin. So if your enclosure is heated a lot, then these then dry down and cool it down due to the heat dispersion, right? And then after the designing, there comes the analysis part. And for the analysis, heat transfer is the most important part, because once your cell is in the discharge condition, it will heat up.
Screen not visible.
Heat transfer analysis screen is not visible?
Yes, yes. Screen not visible.
That is visible.
No, sir, it is visible there. Now we are in thermal management and this slide.
Okay. So yes, heat. Next topic after the designing is always the analysis. Suppose this is true for anything, even if you are designing the structure or chassis or any part. This is valid for all the designs. Once you design, you must analyze it. Be it ANSYS, SOLIDWORKS, Stadia, or any software which has a analysis capability, you can analyze it on anything. So as the battery is the important part, so we should analyze them. That is the first priority for us. So we have a different kind of analysis, but for this class, we will be restricting ourselves to the heat transfer, because that is among the most important and the priority for the battery thing. So for the ANSYS, we do it on the ANSYS Fluent. This is sub part of whole ANSYS software that ANSYS provide. So for this study, what I have done is I have taken one cell, and this this is for 100 and 100, 100 by 100. So what you see inside is a isothermal cylinder. Okay. And what we will be doing with this is we will be seeing how the heat will dissipate if there is only air. This come very handy. Suppose if your one cell is heating up, right? So you know at what distance you should place your another cell. So it can dissipate the air or anything that is inside. It can dissipate the heat, excessive heat. So they don't burn it off easily. So for this, what I have, these analyses are usually done on 2D. They are not done on 3D because of their lengthy procedure as well as the cycle that we go up to. There are like 1,000 or sometimes 10,000 of iteration going on in the batch panel of the ANSYS. So we restrict ourselves to the 2D analysis only, and then we, after the analysis result, we get our idea that if this cell is placed like this, then this must be the area which we need to omit out for net cell. Right. So in the heat transfer analysis, in the heat transfer analysis, there is a part that is a thermal management that we generally do in the ANSYS. So in this picture, you can see this hollow that you see is the cell. So if for this thing I have taken cell heat as a 250 Kelvin. Okay, so once it start dissipating, once the heat start moving for the one, because this is a theory, like if there is a heat, it will move out to the colder region. So suppose this whole square box is filled with the air only, and air is neither cold nor hot, but a normal room temperature air. So once we put this cylinder, cell, and we give it a temperature of, suppose for this thing we have taken 250. And then we will go with the pressure counter, how this temperature will exert a pressure on nearby cells. So you see this red area. This red area is actually an area which you need to consider. Like this area, once it start dissipating, is my cursor visible?
Yes, sir, visible.
Okay. So this area which you see with the dark green area, right? Once heat start dissipating, this will eventually, after certain iteration, it will eventually cool down, but the heat will flow outwards, right? So you see, once you, after certain time, the heat will be on the outer part rather than inside part. This cell will come and cool itself down, and the heat will flow inside. So what you see here is the pressure counter taken out of one single cell in the 2D analysis of ANSYS Fluent. So yes, in this, due to this analysis, we can optimize our design. If you see our placement, cell placement, you get an over idea. Like once heat will start moving, it will move out to a certain length. Right. This is one certain pattern that heat will follow. So you can optimize your design accordingly. You can give either the safe space between these two cells, or you can add some material, like if you can add FR4 or something, you can use them as well. Or if you have a coolant, nowadays there are coolant in the market as well for cooling down these cells. So what they do is, at the edges where you have a outer cover, they use the same fins as well as some liquid into those pipes, and they act as a coolant. Once the heat heat reaches to the end of the enclosure or inside of the enclosure, they will act as a coolant, and then for the outer part, for the outer enclosure, these these fins act as a coolant to them. Okay. Basically, what fins does is they increase the surface area. So once you have a larger surface area, it will help you down. It will help you in cooling down the things. Sorry, please mute yourself. Please mute yourself. So we are done till thermal analysis. Thermal management. Also, in this we can do one more thing. We can add a cluster of cells in series and parallel and do a 2D analysis that will help you in gaining much more idea, like how the heat, if you have two cells in a parallel or in a series, then how the heat will dissipate. Because if you can see, if you add one more cell over here, right, it will have another area. So this area can increase, or it can help us, or it can help another cell in cooling down as well. So suppose one cell is overheated, another cell is not. So it can help you in reducing that as well. Also, after this, you can, after these thermal management and performance batteries, we usually go with like what type of coolant system we can use. So suppose if you have a larger heat issue and your surface area or the volume, if you see, volume is less, right? So you can use heat sink much more in the pattern inside and outside. And if suppose you have a much lesser area, you can use a side fan or the fan that we generally use in CPUs. Right. Generally for these, they are used for battery management system. They are using the fans that we generally use for processor in our laptop. 2 degree or 3 degree, two-way open or 3-way open. So you can use them as well. Or you can also do one thing during the BMS, you can keep a certain temperature limit. After that, suppose if your BMS has a temperature limit of 200 Kelvin, right? So what it will do is once it detects the temperature or humidity, or not humidity exactly, but if it detects the temperature or the pressure or velocity of heat, if heat, how the heat is moving, goes beyond its capability of handling it, it will simply cut down your battery. What does this mean? Your battery will certainly stop until it goes below the mark. So you can see in these EV bikes, there are certain things whenever it detects humidity around the battery, it gives you a warning onto your mobile app or on your display that is in your EV, right? And after that, it gives you some time, like you have 5 minutes or something, you can, so that you can reach it at some comfortable location where it will stop down. It doesn't break off, but it stop down and it tries to cool itself instantaneously. So this thing also help us in improving the performance and the lifespan of our cells. Basically, in these cells now, what happens is you don't have a lifespan of whole battery. Like you generally see a lifespan of a one cell. So once you made a cluster of these cells, these lifespan of each cell become very important for you to understand how your battery will be performing over a certain period of time or certain period of suppose 3 years or 4 years, how you will be replacing them, these things. So in analysis, now we are moving towards the result, what we do. So whenever you do the thermal management analysis or thermal analysis or convection analysis in ANSYS, we usually go with 3 results. One is pressure, obviously. Then another is temperature, which I haven't mentioned it here. But once you have a cluster of cell, your temperature result make more sense. If you have single cell in it, your temperature result doesn't make much sense. In that case, these pressure and velocity curves or graphs or photos or whatever you say, these made more sense than the temperature. So in the analysis result, there is one velocity aspect as well. So what does this velocity means is how the heat is dissipated. At the edge, you can see these arrows, right? And sorry, please mute yourself, please. That's my last request. So yes, analysis result. We were discussing about velocity. So velocity graph help us in understanding how the heat is dissipated. In this, you can see the whole. Once the heat dissipate, you see these edges. They have a bit yellowish and greenish color. If you see on this graph, it is towards the unsafe area, not exactly unsafe area. Once you move it to the yellow part, yellow part usually means you need to reconsider your design or your placement of component, or you need to redo something so that it can effectively give you a much more lifespan or efficiency or any thing related to those. Right. So at the edges, you see there is green and yellowish pattern that tell you once the heat start moving out, these points are the points where heat will be trapped. So if you all know this greenhouse effect, something the heat comes in and it is not usually able to go out. Same thing is with this part as well. This cell is enclosed with the boundary. The boundary either in the material form, in the metal form or in the plastic form. Right. So these boundary will have its own effect. Once you have multiple cells arranged in pattern, they all will throw out their heat at the outward. Because if you explode this thing, basically it is telling you that the heat is moving outward. So at the edges there will be a heat, which you can say the heat is trapped. So that is why you see in these EVs, especially in two-wheeler, you have a lot more patterns outside rather than inside. They also help you in cooling down the system. But if you see in the four-wheeler passenger vehicle, they don't have these patterns due to the fact because the surface area is itself very large for the four-wheeler passenger vehicle, that it can help as a dissipation for the heat. So these are the things in the thermal heat management. And then the velocity, we have discussed this. And now comes the most important software. This is one of the most underdone software that majorly not much people know it, but it can do tremendous help in your research, in your calculations, as well as in your designs, in your any electrical parameter or battery management parameter. Please mute yourself. This distract me a lot. This is distracting me a lot now. Please mute yourself. Hello. Please mute yourself. Thank you. So yeah, we were sorry, please mute yourself. This is the last warning I am given. Otherwise, I will
Hello.
end within right here. If anyone
Sir,
is so,
Sorry,
Yes.
you can mute the participants. You have the option.
Actually, I don't have an option currently. I don't have that enabled right now. So
Otherwise, those who are disturbing, you can remove them. That's
Sure.
the last option.
Sure. So this is the last warning I am given. Please keep yourself muted. We will have a questionnaire after we complete this presentation or these topics. We will have a questionnaire after that. So our last thing was to we were discussing about the velocity in the ANSYS as a result. So next topic is MATLAB. MATLAB is one of the most underdog software. Majorly, not very much people or very much professional are involved in MATLAB, but this is one software which can handle everything from your research and development calculation, from your mathematical or your integral problem or calculus problem. It can handle those. It can help you in your heat calculation. These are different kind of calculation that you can do it with MATLAB. You can do even your IC calculation, normal piston engine that we have in cars. You can do those calculation as well. Frequency calculation, thermal and electrical responses. How your wire will respond if you pass some amount of current. Suppose if you have a wire which is not able, which you want to know, like how it will react if 20 ampere of current is going through this. So you can do those study in this. There is one more add-on to MATLAB, that is Simulate, which is an added capability, but that requires its own language. MATLAB is actually one language which resembles to Python somewhat, if you guys know Python, or otherwise you can directly learn MATLAB as well. This is one software which has a lot of scope in future in EVs, in autonomous vehicle, in a connected vehicle, or in any technologies that is developing with the AI or something. Even in 5G tools, you can use those analysis part in MATLAB Simulate. So for our use case, we will be exploring how MATLAB is used in as a software. It is used in battery pack modeling design. So one thing that is MATLAB used is for the calculation. Suppose the calculation can be in the electrical part, it can be in the mechanical design in front, or it can be in the form of any simulation. Suppose if you have a capability of heat, which then our material, this material can hold up to certain amount of heat or some certain amount of frequency. Even once the current move in the wire, there is a frequency or vibration into those. If you see these high tension wire, they generally make a sound. So that thing also happen in these smaller EVs battery packs. So yes, next thing in this is you can make the path architecture as well. So in early slides we have discussed these architect, how we are placing them. You can make this architect in your MATLAB as well without doing it physically or putting your larger effort into this. You can simply do that into the MATLAB, right? And then after doing all those things, evaluation, calculation.
Me?
Yes.
I think your screen is not visible to all of you. Can you please check with the screen?
Actually, it says you are not allowed to share your screen.
Give me a minute. Can you please check once again?
Okay. So yes, MATLAB. Yeah. So after designing these artifacts, you can always evaluate them. Thermal. You can even script ANSYS if you are doing things on the MATLAB. So this is the one software which can help you in complete development of the product from the scratch. All right, and then it have like everything: mechanical, thermal, electrical, even your this thing, BMS codes, as well as enability of computer codes programming as well as. So currently in the market, MATLAB is used. The larger company like Ola, they are using MATLAB as an first source for developing BMS algorithm, right? And for their safety operation as well. Just now in the few minutes back, I told you like BMS is help us in controlling the heat and multiple things. So what exactly BMS is? BMS is the brain. It is a battery management system. Suppose we have one programming code in our phone, right? If you go with the Android phone, you have processor into it. So BMS is kind of a brain to it, which allow user to have a view how your battery is reacting to different kind of things. So MATLAB is one software which is extensively being used in BMS. Currently, Ola is one of best example who are exploring MATLAB. Even Siemens is exploring MATLAB as their first source for their machines and these. With MATLAB, there are other, similar to MATLAB, you can find open source. MATLAB is actually very expensive, so you can find open source software similar to MATLAB. They both have similar capabilities. You can do everything, but there are few things to like changing language or changing code pattern into those. Otherwise, everything is almost same. So yes. Yes. So after those BMS, we as a MATLAB calculator part, state of charge and state of health and state of discharge. These are three parameters in battery life. So what does state of charge means? What will happen to it whenever the cell or battery is charging? State of discharge is when it is not charging, and it is just you have kept those cells in the ideal condition. There is no ideal condition in this. Even if you keep the cells outside, right? If you are not even using, there is always be a state of discharge. So state of discharge is actually important part for knowing how the cell lifespan will go on. So if you see these business which have battery swapping, right? They have what they have done is they have made three categories of batteries. Suppose for one battery whose state of discharge is really high and good, so they are allowing it also have a state of charge is really good, so they directly give it to the passenger who need it most, right? So their cost price is also a bit high. So in the second stage, they have a battery cells which have a lifespan of, suppose, let's say 50, or not exactly 15, so suppose 60 or 65% is their lifespan. So they keep them in the separate division where they have a different charging capabilities as well for them. So in the third part, they generally use those cells which have a lifespan of 40 or something. So these cells which have a lesser lifespan or capabilities, suppose let's say for our example it's 40, they keep it in the third division, and these three different battery pads. Now they are used in three different things. For the third one, which we have discussed, which have a low state of discharge and low state of health, they are used in autos. Suppose not these CNG autos or something. Directly those three-wheelers that use EVs or EVs autos that we generally say rickshaws or something. Right. So they keep those third type of the battery in for those things. And second, for other two types, they generally keep them for the two-wheeler passenger vehicle or four-wheeler passenger vehicle. Okay. And yes, for when you buy some cell or buy some battery, there is a data sheet which have geometries, topologies, and behavior, how cell will behave. Generally, it is dependent on three factors. One is mechanical factor, which include the geometry. Topologies, again, it comes under the mechanical factor only. And then there is the electrical factor, and then there is the computer factor, that is BMS. So for designing those data sheet, because whenever you sell these batteries or sell to someone, you need to provide them with the data, that data sheet that says correctly says what are its capabilities, how it will gonna react, and what are the these standard you are maintaining. Right. So at the end of those, it will compare you with the what data to. Sorry. Yes. So at the end of the treat, it will give you a comparison, a brief comparison between the standard that is available in the market and what are the parameters that this battery or this cell is having in it. So that are three software that we extensively are using for the battery pad designing: SolidWorks, ANSYS, and MATLAB. But MATLAB is one software that I suggest almost every engineer to go through it, because it has a varied capabilities from designing. It don't do the designing just like we do in SolidWorks or CATIA, but it can help you in pre-designing states. Suppose you are in you want to design, you want to do these cluster, right? So you can directly put it onto the MATLAB and then calculate everything, like how will the heat will flow in and flow out. With MATLAB, there is one more capability that you can use Python as well, but that is not like into the mechanical syllabus or electrical syllabus. So, but Python is again one thing that with MATLAB can do wonders. So by these three factors, if you redo these, then once you design and once you analyze, you can make your battery pad efficient, as well as increase its lifespan, as well as you can also give your customer a belief like this thin burn-in effect or something will not happen, because we are doing these at the back stage. We are calculating everything. We are calculating the heat. We are calculating the design constraint and how the flow will happen into these. So these all things come in handy. Obviously, they are three different fields. SolidWorks is simply a design field that generally mechanical engineer pursue. ANSYS is a CA field, again that generally mechanical engineer pursue. MATLAB is into the electronics part as well as in computer science. But this software can be learned easily, and with its capability, even the mechanical engineer can explore the other side of electrical and computer science with a little coding. There is a coding involved in MATLAB, but again, this can review a much larger view about your battery pack and everything. So here I end my presentation with these. So now we can go ahead with question and queries. Am I audible?
Yes, sir, you are audible.
Okay. Now let's move it to the question and questionnaires. So first one in the list is Rakshit. Please unmute yourself.
Hello.
Yes.
Yeah. Hi, sir. So when we are designing a battery or a battery pack in ANSYS, how do we exactly translate that electrochemical behavior into ANSYS?
Sorry, I was on mute. Actually, we don't design it on the ANSYS. But once you design it in the SolidWorks in designing software, you can move it, import it into ANSYS, and in there you have an option. Once you move the part into the Fluent, you have the option to give it energy. Yes, to give it an energy equation, electrochemical equation, or any chemical reaction that is happening inside or outside. Right.
So yes, sir. I've explored this area, and there are 3 or 4 electrochemical models available in Fluent. So NTGK model, ECM model, and such.
Yes.
Yeah, but I'm not sure how to use those things. So if you could point me to some resource where I can learn these things, it would be really.
For this resource, I guess ISIEINDIA also have a resource onto the analysis of these battery. Otherwise, you can do one more thing into the theory part of ANSYS on their website. You can explore those theoretical aspect. There is no practical thing available over there, but you can explore those theory and implement it for your own self.
Okay, all right, sir.
Okay.
Thank you,
So, yes. Next is Dhanesh Kumar. That's it. Please remove your hand. Pull down your hand. Okay. Alok Singh.
Sir, hello.
Yes. Yes, Alok. Yes.
So my question is that presently in all the batteries that we made is made up of lithium.
Yes, lithium ion. Currently,
Yes.
we are using LiFe PO4,
Yes,
lithium
sir.
iron phosphate.
Yes, sir. So, sir, like the research is going on, like the alternative material for the batteries, like the sodium and nickel or cobalt something. So,
Yes.
sir, if someone is using a sodium battery to test or analyze the result in ANSYS, so is it possible to give the comparison between this Li battery versus the sodium battery in ANSYS? Is it
For the
possible?
Li literal battery, you can have the comparison. You can do 2 different studies, but for this in the sodium batteries, you need to get some data from the internet as well. Because last time I checked with ANSYS, there was no drag and drop kind of formulas or information in ANSYS. But by the end of this year, ANSYS will throw one update with the data. So, but for now, if you want to do something regarding that, you can get the data from the. Okay, Alok, am I clear?
Yes, sir. And sir, one more question is that, sir, in my university, there is some project going on, like using the water-cooled battery management system. And there is another cooling system for battery management. So, sir, what's your point of view? Like the Ola bike makers, their battery explode in the summer conditions. So, is it because temperature or
Where are those?
Please go ahead. Vitri, just a minute. Let him complete his query. I will come to you after that. Yes, Alok, please.
So my concern is, sir, like the problem is with the temperature that the battery is holding, or is it the problem with the material that battery is holding?
To be honest, these cells and battery, they are not adapted to the Indian climate. Indian climate varies. We generally have a humidity and high temperature. From the north to the south, temperature varies a lot, right? So these are not adaptable to Indian weather and temperature. That is one reason. But nowadays there are cell building and manufacturing happening in India. So before buying batteries, that was I told you before buying batteries, you can go with their data sheet and read what are the optimal temperature for them, what are the optimal weather for them to be in the usage condition, right? So let's move into Samuel. Samuel, are you there? Okay, Viti, you throw your question first. Hello.
Hello.
Yes, Samuel, please ask your question.
No doubt, sir.
No doubt. Please pull down your hand. Viti, your question? Sorry, you were saying something? Okay, Viti, your question? Jet, Viti.
Vicky.
Yes.
No, sir.
Hello, sir.
Sundar.
Do anyone have any question they can ask right now? Okay.
Yes.
Good evening, sir.
Sorry.
Good evening, sir. I'm Manikanta. Sir, may I know, which type of software is using, sir? SolidWorks and ANSYS. Which version are you using, sir, for doing this type of work? Which type of version is suitable for doing the design and the analysis work?
Look, for the designing, you can use SolidWorks, Stadia, or anything, whatever.
Yes, sir. SolidWorks version is there, sir, like 2021. Anything is okay, otherwise?
Yes. Anything is okay. It is not dependent upon the version. You can do anything with even the same thing with the 2012 version. But the thing is, there are new updates available every now and then. So you can use any version available in the market. So next person is Surender.
Vicky.
Sir.
Yes, Surender. Please ask your question.
No doubt.
उलेरा जाओ.
चल रहा है.
Chowta जाओ.
Viti, please mute yourself. If you don't have a query, please don't unmute. Nishant Bhardwaj, you are the next.
Hi. Audible?
Sorry,
Hello.
Nishant, you are audible.
Yes, I'm audible.
Sorry, could you please repeat what you said?
I am audible, sir.
Yes,
I am
yes.
audible.
Yes.
Yeah. Sir, my question is like most of the four-wheelers that we are seeing right now, they are coming with lithium-ion batteries and with liquid cooling, like water cooling and some
Yes.
coolant cooling, sir. Like,
Yes.
but in some of the OEMs like Citroen, they have launched like EC3 vehicle in Indian market. They are using lithium-ion batteries, but without any liquid cooling they are giving in their battery and without fins on their surface. And in their brochures, I have come through and went to the OEM as well. They are saying that this is a natural air-cooled battery. So how it is possible with the lithium-ion battery with so much cells and so much kilowatt-hour battery rating? How they are by natural air cooling, they are cooling their battery?
Actually, there could be a possibility that there is some fin opening to some part, right? If they are saying naturally cooled, either they have, I can guess one thing with them, either they have placed their cell at a certain distance of these things. So if the heat will move up to the extent, then that cell is somewhere really far, or they are using some other thing, maybe some opening or something. But again, you need to check them, because these OEMs and researchers, they always come up with something new. So you need to check like how they are.
But the one thing is that they are using prismatic cells, not cylindrical cells, like in the most of the EV batteries we have seen. Like, so is there due to prismatic cells they are able to
Yes.
do with the natural good?
Yes. They actually, there is no thing like naturally cooled. What they do is they keep cells at some distance, so it cool it down by its own self.
Okay. Maybe it will be solely dependent upon the placement of cells, how far they are placed from each other, and how efficiently they are packaged. Okay.
Yes.
Got it. Thanks.
Tanmay Maharana, you are next. Yes, Tanmay.
My question is to define the boundary conditions for the structural analysis of the cell. I mean the outer cover of the cell. So how it is correlated between AIS 156 and to define the boundary conditions?
Actually, defining boundary condition is completely dependent upon your area. Suppose I have used one cell, my boundary condition was a square of 100 by 100 mm. So it can vary. For the professional reason and the guidance, there are multiple codes available in the market, as well as government is coming up with its own nature of regulation, which these engineers now after a while have to follow while developing the batteries and these things. So Hari is ready. You are next.
Sir, am I audible, sir?
Yes.
Sir, my question is, what are the challenges might arise during the battery design process, sir?
What are the actually challenges nowadays? There is one challenge only, that is heat.
And how can this MATLAB and SolidWorks and ANSYS tools help to overcome them, sir?
Yes. So these software gives you an idea before your things collapse, right? So if you suppose you place cells at 10 mm difference, you can do those study in ANSYS, and then you will get to know like this cluster will fail out. And then you will move it around, you will do 15 mm, 20 mm, and these things will help. These are just the basic. Once you deep dive into the advanced concept, you will believe there are a lot of things that affect the battery life, health, lifespan, and many things.
Thank you, sir.
Next person is Kalidas. Kalidas, please show your question. Okay, Rahul Kumar, you are next. Rahul?
Good evening, sir.
Yes.
This is Sadiq Shid.
Please go ahead.
Sir, what are the best materials to enclose the batteries?
For enclosing the battery, there are FR series material, FR4, FR5. Basically, FR stands for fire resistance. They are a composite of fiberglass, cloth, and epoxy resin blended into them. So what we generally use is we make cell cluster and then put these FR material.
Sir, why can't the Ola bikes didn't use these type of materials to prevent the fire from the
They have used, but the thing is these materials also have a limited capabilities. Once your heat goes beyond 250 or 350 Kelvin, they also burn off, right? So they have a not exactly 350, but they have a higher heat resistance capability. But once they reach those parts, they will not be able to resist those. Plus, there is one more thing for FR series material. You have to enclose them really well. If there is some opening at some point, it will not be beneficial for them for the motor.
Okay, sir. Is there any chance to control temperature by the other methods like
Yes, you can control temperature using BMS. Once type I already told, like BMS cut off its current and voltage. to self-tool them. This is an example of self-tooling, right? Like it will cut it off. It's usage.
So why can't we use the air-cooled system like radiators?
Radiator, actually, it will be very difficult to place them. Plus, there is one more thing. For radiator, you need a opening, right? So you can't have that much opening in two-wheeler passenger vehicle.
Okay, sir. Thank you.
And next is, please mute yourself. Next is Durba Roy, if I am pronouncing his name right.
Yes, sir. My doubt was when we are designing a battery that has fire-resistant coatings inside it, we also have to they are fire-resistant, so they might be resistant to heat as well. So if we are using such material, how are we cooling the battery down? For efficient cooling and the transfer of heat, we have to use some kind of preferably aluminum or some things that transfer heat very rapidly. So how do we counter that situation? We have to mitigate heat as well, and we have to make a fire resistant material as well. So how does the fire resistant material transfer heat? How do we solve that problem?
Actually, fire resistance, they are resistant to fire, but they don't. They are not resistant to heat. They absorb heat, but because these things they are completely sealed off, right? These material are completely wrapped off, so they will absorb heat, and then there is the outer cover that will also absorb heat. So for your thinner, like we use aluminum, and these we generally use aluminum for setting these parts. If you see these wrap, if you can see my cursor, there are these wrap, right? Then there for the loading them and giving them a space, there are aluminum things that we generally place them between those. Okay.
Okay, sir. Thank you. Yeah.
Okay. And now just two more questions, and then we will wrap up. Let's go with Nani Patnaik.
Yeah, so good evening, sir.
Good evening.
BMS is one of the main BMS is to manage temperature of the battery, right?
Yes, not exactly battery, but it can manage multiple things. Your battery life, charging capabilities, and
yeah, one of the function is that it does multiple, but one of the function is that. But still, when we are facing exploding of battery, all that due to temperature, is that BMS malfunction or something else?
Sorry, could you please repeat?
Batteries and all that,
Actually, voice is not very clear. Sorry, your voice is not very clear. Could you please repeat once again? I'm really sorry. Please.
Now is it clear, sir?
Please mute yourself, Samuel. Please mute yourself. Let me listen to her.
So now is it audible?
Yes. Please go ahead.
So one of the function of BMS is to manage control the temperature of battery. So still we are facing exploding of batteries due to temperature rise and all that. Is it the malfunction of BMS or something else is affecting that?
Okay. Actually, there are both things. If you see few of the incidents, they went unreported due to BMS thing, right? Because BMS also is imported one. Right. There is no... Samuel, please mute yourself. This is the last time I am telling you. So next onwards, you will not be allowed in any webinar.
அன்னைக்கு ஒரு நாள் போட்ட பொண்ணிங்க தான் போட்டீங்க அதான் கேட்டேன்.
Please mute yourself.
ஆயிருமோ போன வரும்.
Puneet, I think they are not interested in listening the questions and answer session. Okay.
You can please remove this. I will answer her, and I will take one more question, and we will end this. So yeah, what I was saying is there are a failure to the BMS as well. If you see if you see all the reports that are coming into the news, there are they are due to the failure of BMS as well. BMS is also responsible for these. Sometimes what happens is due to excessive heat, the wires burn off, so it was not able to send the signal to BMS. BMS was not able to get the exact temperature reading. These things also are happening over there. That is where MATLAB comes very handy in knowing everything. Right. And next person, let's go with Nishant 105. And then Chinmay Patel, you are last. We will end with you. Nishant, please throw your question.
Sir, my question, what is SOC and SOH, sir?
Actually, SOC is state of charge and SOH is a state of health, like what health you have for your cells. You denote your cell with the lifespan, right? So SOH helps us in getting those information. There are various aspects to SOC and SOH that we will explore in some other webinar. They are beyond certain details and everything, because there are numerical factors as well for calculating SOH and SOC. Chinmay Patil.
Good evening, sir.
Good evening.
Sir, what are the methods for increasing the battery efficiency? Like all the vehicles are using the batteries, and for increasing the speed, what are the methods for increase the speed for battery average or efficiency?
Actually, for efficiency you can increase, but for speed and these things, they are actually not very much important area currently, but the life and health as well as for the batteries are most important thing. So multiple research are going on to these factors. Again, if you have a high charge now, then the discharge will also be very high. This is a parallel thing. Charging is fast, discharging is also fast. So let's wrap up. I hope I have answered everyone.
Hello, sir. One more question is there. Sir, can we use heat pipe for reduce the heat in batteries?
We can use thermal pipes.
Yes, is it possible, no, sir?
Yes. It is possible, but again, the area and volume depends. If you have a lesser volume area, you won't be doing with the pipes because it will consume your volume. So let's wrap up this. I hope I have answered every question of yours. If you have any further query, please write back to this mail, and I will be happy to assist you. Thank you, guys.
Thank you, Puneet. Thank you, Puneet, for the session.
Thank you. Bye. Take care. Have a good evening and a great weekend ahead. Bye.
Kashish, over to you. Kashish, want to say something? Kashish, over to you.
Thank you, sir. Hello, listeners. Thanks for attending the webinar. I hope you all like the webinar and looking the exposures to enhance your learning and skills in this EV domain. So here I would like to introduce ISIE India products, which will help you enhance your skills. So come take a look of a small video about ISIE India courses that helps to enhance learning and gives the opportunities for the placement. Okay, have a look.
And want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISIEINDIA India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have a range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship, to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Okay, thanks learners for watching this video patiently. Hope you guys have understood. Yes, Puneet?
Actually, Ankur Rastodi has one doubt earlier. I forgot to mention his name. Ankur, do you have any doubt or is it clear?
Hello.
Yes, Ankur.
Yeah, I have a doubt that recently in your presentation you have shown that you have labs.
Labs?
Yeah, in your presentation, ISI India, you have the test labs.
Okay. That you can directly get in touch with ISI India.
Okay.
Wow.
So where these labs are situated? In your Noida region or what?
We have set up the lab in Noida region as well. Apart from the Noida, we are having our labs in Kerala, Aurangabad, Shirgaon. So we are setting up the Center of Excellence lab for the e-mobility throughout the Pan India. Like if you are interested in setting up a Center of Excellence lab at your campus, so you can drop us the query.
Okay, fine.
Yeah.
Okay, guys. Bye. Take care. Have a great weekend ahead. Bye. Signing off.
Thank you, sir. Thank you, Puneet. Kashish, you can continue.
Sir, is there any certification, sir? I mean, participant certificate.
The certificate will be received within 24 hours on our mail ID. Okay.
Thank you, sir.
Kashish, you can continue.
Sir,
Thank you,
is there
sir.
any specific? Sir, is there any specific channel on YouTube or something? Any social media do you have?
Pardon, can you please repeat it again, Abdul?
Sir, do you have any YouTube or social media account?
Yeah,
so
we have our social medias and YouTube account. You can find out with the name of ISIEINDIA Charging.
Okay. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay, learners, hope you guys have understood the products. So any of you wants to enroll in the courses or interested in the course, kindly send us the inquiry through a QR code.
QR is only for the course inquiry, not for the certificate, any other things. Okay. If you are interested to join any of the program of India, you can just scan the QR code. Okay.
Okay, sir.
Thanks, Render, for joining the webinar. Hope you like the webinar. Okay. If you are interested in joining of the course of ISI India regarding the electric vehicles, you can scan our QR code.
Thank you, sir.
Yeah.
Thank you.
And the feedback form link is given in the chat box. You can give the feedback as well.
Bro.
Thank you, sir.
Sir, our doubt